Hi dear students, this is Dr. Moga, and today we're going to be solving paper 6. We'll start with the question 1, which is Feb-March 2025. A student investigates the behavior of a spring and then uses the spring to determine the mass of an object. The apparatus is shown in figure 1.1. The student suspends a mass m is equal to 100 grams. So we're talking here about the mass. From the spring, she measures and records in table 1.1 the stretched length L of the spring as indicated in figure 1.1. Describe two techniques for measuring the length of the spring to ensure an accurate reading. You may draw a diagram. Whenever they ask you to measure the length in an accurate way, the best way to do that is, of course, if you're using a ruler to measure your length, then your ruler needs to be closer to the spring. So have the ruler close to the spring. This is the first way to have an accurate reading. Second way to have an accurate reading is to use something even better than the ruler, which is the set square. And what's a set square? It looks like a triangular ruler. It looks like this. I'm sure you've seen it with your math geometrical apparatus. So what does this do? It makes sure that your reading of your measurement is perfectly aligned. It's not tilted at a certain angle. It's exactly at 90 degrees. So my second option to measure the length accurately is use a set square to measure the length. Okay, so use a set square to measure the length of the spring. All right. The length of the spring. Now let's go to the next part. I hope my handwriting is clear. She repeats step A for values of m, 200, 300, 400, and 500. Her readings are shown in table 1.1. Plot a graph of L per centimeter in the y-axis against m per grams in the x-axis. Here they gave me a hint which will give me 1 mark in this question. Start the axis from the origin 0, 0. Draw a best fit straight line. This is my second mark. And the line might not go through the origin. So don't force your line to go through the origin. Now let's do that. In the y-axis, they said L dash centimeters. And in the x-axis, m slash grams. Now my next task is to know how to divide them. For the y-axis, I have from 6 to 21. But of course, I have to start at 0, 0. So I will have to break these down. I need to count the squares. So I have 2, 4, 6, 8, 10, 12 squares to fit in my 21. So easily, I can go all the way up to 22 and maybe even 24. So I'll just do 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22. And as we said, we can go all the way to 24 because we have 12 squares. Okay. For the x-axis, I have from 100 to 500. So I can do each big box with 50. So that means that each 2 boxes are with 100. So 100, 200, 300, 400, 500. This is what the third mark is all about. The third mark is that you need to cover at least half of the graph. So I always ask my students to make sure that they covered 3/4 of the graph so they wouldn't lose that extra mark. Okay, now let's start labeling. For 100, we have 6. Oh, before you start labeling, I just want to give you a trick because we have decimals in this table. As you can see on my y-axis, I have between, for each big box, which has 5 small boxes, I chose the difference to be 2, right? Now I have 5 boxes. So if I do 2 divided by 5, it's going to give me 0.4. This means that each small square is with 0.4. Why is this information important? Because I have values in significant figures. Okay? All right, so 100 is at 6. So always draw a cross, not a dot, because if your ink is a little bit light, it's not going to show. Okay, 200 is 9.2. So at 200, I'm going to go all the way. We have 8.4, 8.8, 9.2 is the third line. Then we have 300 is a 13.6. So at 300, I'm going to go all the way to 12, 12.4, 0.8, 13.2, 13.6. Okay, for the last two, 400 is 16.8. So at 400, I'm going to go to 16, 16.4, 16.8. And the last one, 500 is at 21. So at 500, I'm going to go, here's 18 and 20, and 21 is between 20 and 22. So it's right there. Next, I need to draw a best fit straight line. So the line is not going to go through all my crosses, but I have to make sure that the crosses could be on the left or right side of my line, which is absolutely fine. And as they said, it's not going to go through the origin, so that's fine. Okay, this is not a perfectly straight line, but you should use a ruler. All right. Next, use your graph to determine the length L0 of the spring with no load on it. No load means that the mass was 0. So at the mass 0, where did it hit exactly? It hit at around 2.2. Yeah. Okay. Next part. Here they're asking us on figure 1.2, measure the stretched length L of X of the spring. You're going to use your ruler. I'm using my screen, so the ruler will not be efficient, but I've already measured it on the paper, and it gave me 10 centimeters. Use the graph and your reading from DI to determine the mass mx of object X. Show clearly on graph how you obtained. Here there are 2 marks, one for getting the number and one for showing clearly how you got it on the graph itself. So let's go up, find my 10 centimeters, here they are, and I'm going to draw using my ruler a line to see where it's going to hit. It hit exactly between 200 and it's exactly 215 actually in my case. For you it could be a bit different, a bit lower, a bit less. Anything between 180 and 240 is correct. So if you got your answer between 180 and 240, then it's correct. Okay, last one. 2 students measure the mass of another object using the same method and apparatus. One student records the mass as 132.6 and the other as 130 grams. Say and explain which answer has the more suitable number of significant figures for this experiment. How will I know? Most of my students would just tell me, okay, 132.6 is more specific, this is the correct answer. But that's not what he said. He said more suitable number of significant figures for this experiment. So what I need to do is I need to see the mass that was used. I don't have any decimals in my mass. As you can see, it's 100, 200, 300, 400, 500. So obviously, the more suitable one will be the one with less significant figures. So I'm going to say that 130 grams is more suitable. Why is it more suitable? Because it's like what the data values in the table above have less significant figures. Perfect. That's all for today, and that's how you guarantee that you get 11 out of 11 in this question. Have a good day.